This is the grand finale for chapter 11. We are going to look at limits at infinity. So, this is where Toy Story comes in because this is when you are going to infinity and beyond. You're going to be like, I wonder what the limit of that function is at infinity and beyond. So, today is when you finally find out. This is not new math. I've taught you this before, your Algebra 2 teacher taught you this before. The language and the notation is different. But what we're really learning today revisits the idea of a horizontal asymptote. And in a horizontal asymptote, okay, there we go. That is what the ends of your graph approach. So back in the day, we did graphing of functions like these, and we would factor and cancel and find out where were the vertical asymptotes, where were the holes in the graph, where was it increasing, decreasing, and we would find out where were the horizontal asymptotes. That's really what we're doing here, because whatever the horizontal asymptote is, that's what the graph is going to approach. So if I have a graph and a horizontal asymptote at 2, and maybe I have a vertical asymptote, that's telling me that no matter what this graph does, it's going to, at the ends, approach that y value of 2 if that was my horizontal asymptote. So we're doing limits as you approach infinity. That's because on this end, x is approaching negative infinity. So whenever you're asked what's the limit as x approaches negative infinity, that's really the left side. And what's the limit as x approaches regular infinity would really be what the right end is doing as it goes off this direction. For today, they're all just plain old infinity, and so we're going to go back to think about how we did horizontal asymptotes. What this did is this would make us compare the top and the bottom powers. And there's 3 scenarios. So maybe you can kind of think back with me. All we look at is the degree, which means this leading coefficient. In this case, the top power is a 1 and the bottom power is a 2. So I'm in the situation where the top degree is less than the bottom. And every single time that happens and your x is approaching infinity, so you're looking at the ends of this graph, you're going to have a horizontal asymptote at y equals 0. So the language is the only thing that's different today. So today you would say the limit as x approaches infinity of this function is going to approach the horizontal asymptote, which in this case is a 0. So that's your first comparison. All right, next one, limits going to infinity. So this is asking about the ends. So I'm thinking horizontal asymptote. I compare the degrees of the first 2. I don't care about any of the rest of the function, just those first leading leading terms. All right, in this case, this has a power or degree of 2, and so does this. So this case here, the top was lower than the bottom, and in this case, the top is equal to the bottom. So now they have the same value. I don't care that they're both 2's, I just care that they're equal and would more or less cancel each other out. So then if we think back to what we learned, the horizontal asymptote would be equal to what we call the coefficient ratio. Fancy math for these 2 numbers. So I would write in my fancy new language of calculus, the limit as x approaches infinity of this function, where the top degree and the bottom degree are equal, would be the horizontal asymptote. Since the horizontal asymptote would be located here, then my limit will be negative 2/3. So I'm not doing any math. I'm just comparing. I'm looking and saying x to the first power is less than x to the second, so my top is less than my bottom. So in that situation, my horizontal asymptote, and therefore my limit as x approaches infinity, is always 0. Then in the second scenario, where the top and bottom degree or power are the same, I would have a horizontal asymptote and therefore limit value at infinity of y equals whatever the coefficient ratio is. So in this case, that's a -2/3. And my last scenario, if you can't guess, since here the top is less than equal to, here my last scenario is going to be where my top degree, like in this case it's a third, is greater than the bottom. And so in this case, I don't really have a horizontal asymptote. And I'd have to think, okay, this is going to either come out as a plus or a minus infinity. So now I'm going to be looking at what they're going towards. So in this case, if I took -2x to the third and divided it by 3x to the second, these two would cancel one of these. And so I would be left with what we call a slant asymptote. We did this back in the day also, of -2/3 x. Well, what do I know about that? All I did was take these two things and just reduce it down. That would be a line, and it would have a negative slope. So that's what that would look like. So if I have to think a little bit on this. If the limit of my function as x goes to infinity, so that's the right end of my graph, since the right end of this reduced comparison is going downward, the answer to this one, the limit to this one, would be a negative infinity. If I divided the top and the bottom out and got something positive here, so I knew my line was going up, then as x went to infinity, meaning the right end, I would have gone towards positive infinity for a limit. So that one's kind of the one you have to actually engage your brain. These two should be straight up review. Here, what we did back in the day was say there's no horizontal asymptote, there's a slant. And then we did learn how to find those earlier in the year. So I don't know if that's familiar to you or not. Okay, so let's try these 3 examples, and then you'll know everything you need to know. You'll be like experts. Alrighty, so I look at this and I go, aha, it's going towards infinity. It looks weird though, because I don't have one thing. So I'm going to get one thing. I'm going to get a common denominator. This is currently over 1. So to adjust my 4, I would have to make that a 4x squared minus 3. And I don't need to adjust 3 because it's already over what I'm using as my common denominator. So now the question really becomes, what's the limit as x goes to infinity of this function? And I can go back to my 3-step comparison and say, all right, I'm just going to compare these first 2 things, 4x squared over x squared. Since these have both a power of 2, my top equals my bottom, and I'm in the second scenario. When I'm in the second scenario, my horizontal asymptote, and therefore my limit as x approaches infinity of this function, would be the coefficient ratio, because these x squareds cancel each other out basically, and my coefficient would be a 4 over the 1 that's not really written there. So 4 over 1 means this has a limit of 4. All right, this one's actually a little easier because I can just see it's all one fraction. The top has a degree of 2, and the bottom has a degree of 3. So the top power is lower than the bottom. So looking through my choices, that's this scenario. And every single time my top power is lower than the bottom, if my limit's going towards infinity, the limit as x goes to infinity of this function, because the top is less than the bottom, is going to be 0 every single time. Just like the horizontal asymptote was 0 in that situation. This looks terrifying, but it's not. It's written poorly. I can't even see what that is. I'm going to guess it's a cube. So I just have to pay attention and make sure that it's written in the right form, because I can't compare the highest power until it's written with the highest power first. So I'm writing in standard form like we learned to do in Algebra 1, highest power and then the next highest and so on. And then the bottom is already in standard form. I do not care about anything but these leading terms now that I have it in the right order. And I can see that in this scenario, the top is greater than the bottom. No big surprise. Now I have to practice this. I ignore everything except the lead coefficients or lead terms. I think about them independently. Negative x cubed over x squared. X squared would cancel, and my remaining thing would be a y equals negative x. So you know by this time in your life, if you're going to go take calculus, that having y equals negative x generates a line that goes down from left to right. And so since that is negative, my limit of what the right end would be doing would be going towards negative infinity, because this is telling me the line goes down. So when I'm going towards that right end towards infinity, this is going to be dropping down to negative infinity. So this just goes back to relearning this. We did it earlier this year. You did it in Algebra 2, and you're doing it now. And they'll just sort of assume you know that in calculus. So the more you can kind of muster your way through that, the better. There is an 11.4 worksheet. It's going to be on Schoology for you, and then you enter your answers carefully into Schoology and send a picture of that in by Friday, and you will be good to go. Thanks, guys. Bye.